क्वेश्चन करू शकतो सर. मग तसं करायचं का? आता याच्यात मेजॉरिटी कन्सर्न जे आहेत तर इंस्टिट्यूटकडनं जो डेटा घ्यायचा आहे तर त्याच्यामध्ये कम्युनिकेशनचा पार्ट आहे, इंडस्ट्री इंटरफेसचा पार्ट आहे, तिथं इंजिनियर डेटा घ्यायचा.
Is the screen visible?
हे या पॉइंट वाईज मध्ये डिवाइड करून दे.
Yes.
Yes, sir.
Okay, so we are discussing linear differential equation and its solution.
हा जो डेटा तुम्ही म्हणाल
The
सर, की समजा आपण project
standard form of LD is phi of d into y is equal to function of x, where the solution of this differential equation is the value of dependent variable in terms of independent variable, that is y in terms of x. So it is a combination of two sub-solutions, complementary function and particular integral. So we have discussed in detail about the complementary function, which is a solution of homogeneous differential equation phi of d into y is equal to 0. Isn't it? And depending upon the nature of its auxiliary equation, that is phi of d equal to 0, we get a complementary function. We have started with the particular integral, right? In the last lecture, pi, particular integral. Let me show you the last lecture. Yes. So in the last lecture, we have discussed about the formula of particular integral, that is 1 upon phi of d into f of x. Isn't it? Where this 1 upon phi of d is an integrating operator. Right? So that is why the name is particular integral. These are the three methods to find the particular integral: general, shortcut, and method of variation of parameter. Right? So let us discuss one by one. Particular integral. The first method is the general method.
म्हणजे हे असे काही फील्ड आहेत की जे पटकन भरून जातात. मी भरून टाकले तर फक्त नॅक एलडीए सर्टिफिकेट लागते, तर त्याचं ईमेल आणि ग्रुप इथे टाकणार आणि हा पार्ट कम्प्लीट करणार. इथं कम्प्लीट होईल. आता त्यानंतर येतो सेकंड पॉईंट, अकॅडमिक एन्व्हायरमेंट. मग इथे काय स्टुडंट स्ट्रेंथ येते, कोणकोणत्या कोर्सेसला किती स्टुडंट आहे त्यांची किती स्ट्रेंथ येते. मग इथे पुढे हा पार्ट
ठीक आहे, जनरल मेथड.
फॅकल्टीज बद्दल इन्फॉर्मेशन विचारतो. हा सगळं ऑफिसमधून डेटा मिळतो. म्हणजे इथे आपल्याला प्रत्येक डिपार्टमेंट बद्दल विचारायचं.
Hello. The general method. Okay. So let us start with the general method. Let us have the formula first of all. To find a particular integral, if we consider a linear differential equation of first order, first degree, suppose linear differential equation of first order, first degree is phi of d into y is equal to 0. So for the first order linear differential equation, how many roots it will have? कितने roots होंगे उसको? Its auxiliary equation will have only one root, right? And it will have only one factor. So the factored form of this phi of d into y is equal to f of x will be, suppose d minus m is root, then suppose m is root, then d minus m is a factor, right? So phi of d into y is equal to f of x will be the factored form of linear differential equation. So what will be its complementary function then? To find CF, what we do? We consider homogeneous differential equation, that is right hand side to be 0. So we consider its auxiliary equation, d minus m is equal to 0. With this, we will get the root d equal to m. And therefore, the complementary function is CF is equal to C e to the power mx. Yes or no? So this is the complementary function. Now to find the pi, to find particular integral, what we do, first of all, we we consider this equation. Consider, let d minus m into y is equal to f of x. So if we resubstitute the value of d, which is d by dx, and by multiplying by taking y inside, what we'll get, dy by dx minus my is equal to f of x. So this is linear differential equation of first order first degree. Yes or no? Which is in its standard form, where what is p of x? P of x is minus m, and what is q of x? Q of x is the right hand side, which is f of x. Okay? So with this standard form of linear differential equation, we all know that its solution is of the form y into integrating factor is equal to integration of q of x into integrating factor plus constant of integration. Yes or no? What is the integrating factor here? E is equal to I is equal to e to the power integration of p of x dx. So that is equal to e to the power integration of what is p? P is minus m dx. तो क्या होगा? That will be e to the power minus mx. So with this, the solution is y, यहाँ लिखता हूँ मैं, therefore y into integrating factor e to the power minus mx is equal to integration of q. What is q? Q is fx. So f of x into integrating factor, that is e to the power minus mx dx plus constant of integration. So when we divide, when we take this exponential function onto the right hand side, what I'll get? Therefore y is equal to 1 upon e to the power minus mx, that will be e to the power plus mx integration of e raised to minus mx f of x dx plus c e to the power plus mx. Yes or no? So actually this is the complete solution of the homogeneous differential equation, and if you look at this is a combination of two solutions, one plus second, and already we know that this is what, this is the complementary function we have calculated there. You can see here, this is the complementary function, isn't it? So the rest is our particular integral. क्लियर टू एवरीवन? तो यहां से मुझे फॉर्मूला मिल गया कि पी आई इक्वल टू 1/phi of d f of x. That is, what is phi of d? Phi of d is into its factored form d minus m into f of x. So this is the formula of particular integral, and that we are getting it with the help of this, that is equal to e to the power plus mx integration of e to the power minus mx f of x dx. Is this clear to everyone? Everyone, please do reply. This is the formula of particular integral by general method. सबको ये formula clear है? Everyone, please do reply in chat box. Okay. So this is in case of m is root. अगर minus m root होगा तो factor क्या होगा? In case of minus m as a root, the factor will be d plus m, right? D plus m operated on f of x. So if I substitute this minus m root into the right hand side of the first one, what I'll get? E raised to minus mx integration of e to the power plus mx f of x dx. So this is the second formula of general method to find the particular integral in case of minus m as a root. Now, in case of second order or higher order differential equation, it will have two or more roots, right? So that means two or more factors. So our particular integral will be having two or more factors in the denominator. Suppose in case of second order, if we have m1 and m2 are the roots, then d minus m1 into d minus m2 are the factors of phi of d, right? So how do we find the particular integral with the help of this? What we do, we operate one of the factor onto this f of x first with the help of formula above. We solve that integration, and then on the answer we apply the second operator. Like suppose that is equal to 1 upon d minus m. If I operate d minus m2, and then with the help of first formula above, what I'll be getting, this is as it is, and inside here with the help of first formula, e raised to m2x integration of e raised to minus m2x f of x dx, right? We can solve this with the help of this formula, right? So we can solve this integration, and then we'll be getting a new function onto which we operate this 1 upon d minus m1 with the help of same formula. Okay, so this is how the general method formulas can be applicable in case of higher order differential equation. Or what we can do, in some cases we can separate these two brackets or these two factors with the help of partial fraction. So d minus m1 into d minus m2 operated on f of x can be written as a upon d minus m1 plus b upon d minus m2 operated on f of x. And now we know how do we find the values of a and b with the help of partial fraction, right? So this is how we can get the value of a and b, and then on multiplying by fx inside, and using the same formulas above, we can proceed further to find the particular integral. Clear to everyone? These are these are the formulas of general method to find the particular integral. सबको clear है? Everyone please do reply formulas. Hmm? Hello, am I audible?
Yes.
So I'm asking about the formulas. Is the formula clear? For example, if it is not clear, let us see the example. We solve the example with the help of general method. Solve. The first question, suppose solve d square y by dx square plus 3 dy by dx plus 2y is equal to e to the power x. Okay, so the first step towards the solution is we put the operator let d by dx is equal to capital D. So the given differential equation becomes d square plus 3d plus 2 times y equal to e to the power x. So its general solution is, what is the general solution of this? Y is equal to cf plus pi, yes or no? Complementary function plus particular integral. So we find the complementary function first. To find CF, how do we find CF? Consider homogeneous differential equation. तो क्या है इसका homogeneous differential equation? D square plus 3D plus 2 times y equal to 0. So its auxiliary equation is D square plus 3D plus 2 equal to 0. Yes or no? This is the auxiliary equation. So what are the roots of auxiliary equation here? D equal to, इसके roots क्या होगा बताओ?
-1
-2 -1
-2
-1.
-1. Okay. So the roots are -2 and -1. So the roots are real and distinct. So we know the formula to write the complementary function. In case of real distinct root, क्या है? CF is equal to C1 e to the power -2x plus C2 e to the power minus x, or you can write c1 e to the power minus x plus c2 e to the power minus 2x. Clear to everyone about the complementary function?
Yes, sir.
To find particular integral now, we start with the formula. What is the formula of particular integral? Pi equal to 1 upon phi of d into f of x. Right? We substitute phi of d. Phi of d क्या है हमारा? D square plus 3d plus 2. And what is f of x? It is e to the power x. F of x is the right hand side function. ठीक है? तो to use these formulas by general method, we need phi of d into its factored form. So let us write into the factored form. Factored form of phi of d is 1 upon d plus 2 d plus 1 e to the power x. Yes or no? Am I
Yes,
right?
sir.
So let us now operate the general method formulas. We operate 1 upon d plus 1 first. So 1 upon d plus 2 into 1 upon d plus 1 e to the power x. तो क्या होगा? With the help of formulas, 1 upon d plus m को हम कैसे लिखते हैं? It can be written as e to the power minus mx integration of e to the power plus mx f of x dx. देख लो formula. See here, the second formula I'm using, 1 upon d plus m f of x will be equals to e raised to minus mx f e raised to mx f of x dx. ठीक है? तो how do we solve this integration now? We consider the integration separately. Consider integration of e raised to x x dx. तो कैसे सॉल्व करेंगे इसको? We put e raised to x is equal to t, isn't it? So e raised to x into dx becomes dt on differentiating. So therefore, the integration e raised to x x dx becomes integration of e raised to t dt, क्योंकि e raised to x into dx क्या है? dt है. So what the value of this integration is? It is e raised to t only. That is e raised to x. Right? So we substitute the value of this integration into the particular integral after 10 minutes. Okay. So therefore the pi equals to particular integral is pi equals to 1 upon d plus 2 into e to the power minus x into e to the power x. Isn't it? I have substituted the value of the integration there. And now onto this new f of x, function of x, we operate this 1 upon d plus 2 with the help of same formula. So 1 upon d plus m operator on f of x gives e to the power minus mx, so that is e to the power 2x minus 2x, integration of e to the power plus 2x into f of x, where f of x is e raised to minus x e raised to x dx. So that is equals to e to the power minus 2x integration of e raised to x x dx. And this integration already we have calculated, so we substitute directly the value of this integration, that is e raised to minus 2x into e raised to x only. So here you can see the capital D is completely gets eliminated from pi, and that is your required particular integral. So therefore finally the general solution is, therefore the general solution, or we call as a complete solution, is y equal to cf plus pi. What is cf? cf क्या था? c1 e to the power minus 2x plus c2 e to the power minus x and plus pi. pi is e raised to minus 2x e raised to x. Clear to everyone? This is the complete solution by general method. Everyone, please do reply in chat box if any doubt, any question. सबको क्लियर है? जनरल मेथड very good. So you can solve few more questions on this general method. Second, solve d2y by dx square plus dy by dx is equal to 1 upon 1 plus e raised to minus x or plus x, 1 upon 1 plus e to the power x. तो कैसे करेंगे इसको? We find its particular complementary function first. That will be in its capital D form, d square plus d times y is equal to 1 upon 1 plus e raised to x. I hope this step is clear to everyone. ठीक है, we consider its auxiliary equation, that is d square plus d is equal to 0 to find complementary function. तो root क्या हो गए? D equal to 0 and minus 1. Yes or no? So with this the complementary function is c1 plus c2 e to the power minus x. And what is particular integral? Pi is 1 upon phi of d into f of x. तो क्या है phi of d here? Phi of d is d square plus d and f of x is 1 upon 1 plus e raised to x. Isn't it? That can be written as 1 upon d into d plus 1. 1 upon 1 plus e raised to x. Yes? So what we do, we can separate these two operators with the help of partial fraction here. So this will be equals to a upon d plus b upon d plus 1 into 1 upon 1 plus e raised to x. So you find the values of a and b, where a is I think 1 and b is minus 1. So please check it out whether a is 1 or b. So a is 1 upon d and b is minus 1, so minus 1 upon d plus 1, and that is operated on f of x, that is 1 plus e raised to x. I hope everyone knows the partial fraction. So multiply by f of x inside, so 1 upon d of 1 upon 1 plus e raised to x plus minus 1 upon d plus 1 of 1 upon 1 plus e raised to x. ठीक है, तो 1 upon d means what? D means derivative, so 1 upon d means integration. So integration of 1 upon 1 plus e raised to x dx minus, here by using the general method, 1 upon d plus m क्या होता है? e raised to minus mx, integration of e raised to mx into f of x dx, isn't it? तो कैसे करेंगे इसको? How do we solve this? So what we can do, we can multiply and divide by e raised to x here, and here already e raised to x is there, so we substitute e raised to x, 1 plus e raised to x is equal to t in the second integration, and here also we substitute 1 plus e raised to x is equal to t. ठीक है, तो क्या होगा फिर? पुट 1 प्लस ई रेस टू एक्स इज इक्वल टू टी, तो यहां से मुझे मिल गया e raised to x dx is equal to dt, और ई रेस टू एक्स इज इक्वल टू टी माइनस वन, है ना। तो ये सब मैं इन दोनों इंटीग्रल में सब्स्टिट्यूट करता हूँ, तो देयरफॉर पी आई इक्वल्स टू क्या होगा, इंटीग्रेशन ऑफ डी टी अपॉन टी इंटू टी माइनस वन माइनस ई रेस टू माइनस एक्स इंटू इंटीग्रेशन ऑफ डी टी अपॉन टी। ठीक है, तो इसको मैं फिर से सेपरेट करूंगा पार्शियल फ्रैक्शन से, वन अपॉन टी एंड टी माइनस वन को, तो a will be minus 1 and b will be 1, so 1 upon t minus 1 minus 1 upon t dt minus e raised to x into 1 upon t का इंटीग्रेशन क्या होता है, log t, isn't it? So this can be written as log of t minus 1 minus log t minus e raised to x log t, and then you substitute the value of t there. So log of t क्या है, e raised to x plus 1 ना, plus 1 minus 1 will get cancelled, minus log of 1 plus e raised to x minus e raised to x into log of 1 plus e raised to x। ठीक है, तो दिस इज x माइनस log of 1 plus e raised to x minus, this is minus ना, e raised to minus x log of 1 plus e raised to x, and this is your final particular integral. Clear to everyone? Is this clear? Everyone, please do reply. The next question is solve d square plus 5d plus 6 times y equal to e raised to minus 2x sec square x into 1 plus 2 tan x. So this will be for homework. You'll have to substitute this as a homework question. So you'll have to submit this as a homework assignment. ठीक है, is this clear? Any doubt, any question? Everyone, please drop your replies in chat box. Clear to everyone? The general method and its use of general method to find the particular integral. Everyone, please do reply. Yeah. So this is all about the general method, and why we call that 1 upon d as a integrating operator. So if you substitute, if you want to know, if you substitute m is equal to 0 into one of the formula in 1 or 2, you will get the reason. See, 1 upon d plus 0 f of x will be e raised to 0, which is 1, into integration of e raised to 0, which is 1, f of x dx, integration of f of x. So 1 upon d plus d fx will be integration of fx dx. So that is why the reason. Okay? So this is what all about the general method. So this general method is generally used when the note I'm writing here. This method is used when the right hand side function is of the form composite function or a rational function. Rational function means it is of the form p of x upon q of x, or it is inverse trigonometric functions, etc. Okay? Actually, the general method is general. In general, it is applicable to all, but as it is lengthier because of these integrations, we have some shortcuts, but that again those shortcuts are not applicable to all. So depending upon the nature of this right hand side function, we can select the method whether it is to use general or the shortcut. Okay. So this is all about the general method. In the next lecture we will start with the shortcut. So I hope you have noted this problem, this question. You'll have to solve this as a homework. Let me quickly take attendance.